Assalamualaikum and good morning or good afternoon. Okay, so for the continuation of electrical machine is the continuation from your last semester, which is electrical power engineering. So I believe you have studied the basic principle of the transformer from your electrical power engineering. Now to continue based on the last semester, I will touch on the transformer at no load. So what does it mean by transformer at no load? As you can see in the figure 3.6, this is the transformer at no load, where the secondary side of the transformer is open circuit. There is nothing connected here. So this is the condition where the transformer is open circuit. So let me continue again first. The connection diagram of the transformer at no load condition is shown in figure 3.6. The primary winding draws a small amount of current called I/O. So during the open load condition, there is a small amount of current, kena panggil I/O current, or kena panggil as no load. This is also called as no load current. When it is connected to an alternating voltage source V1. As a result of this current, we will get the iron loss in the core and a small amount of copper loss in the primary winding. So if you source the transformer with a supply voltage of alternating source V1, you will have a iron loss in the core and a small amount of copper loss at the primary winding, which can be neglected. So the no load current I/O can be resolved into two components as shown in figure 3.7. These are called the working component current and the magnetizing current. So we can say that I/O is also equal to IW plus IM, where IM is your magnetizing current and this is the working current. So the working component current IW is in phase with the supply voltage V1. And what is the function of this working component current? The function of this working component current is to supply iron loss and the small amount of copper loss. So the iron loss of the iron loss component of current is equal to IW equal to IO cos phi naught. So the other current, which we call as the magnetizing component current, and this magnetizing component current lags behind the supply voltage V1. Compared to working current, it is in phase with the supply voltage. But for the IM, it lags behind the supply voltage. What is the function of the magnetizing current? The function of the magnetizing current is to sustain or establish the flux in the core and the expression of the magnetizing current is IM equal to IO sine phi naught. So if you look at this diagram, IW is in phase with V1, but IM lags by 90 degrees compared to V1. So as a resultant, kamu ada I0. Kena panggil di sini I0. Okay. So if you look at this diagram, since kamu di sini open circuit, you know that at the secondary side is open circuit. So you supply the primary winding. This is we call primary winding. So you supply the primary winding with the alternating voltage V1. So since this is a closed circuit, you complete the circuit, there will be current flow within this circuit. So we call this current I1 because this is a primary side. Since this is a no load condition, we can call this also jadi IO, a no load current. So do we have current in I2 di sini? Do we have current? So if you understand the basic knowledge of electrical circuit, when you do not complete the circuit, there will be no current flowing in this area if you do not complete the circuit. So di sini kamu dah complete circuitnya, pasal di sini open circuit. Kamu open the circuit. So there will be no current flowing at the secondary side. So you do not have current at the secondary side. So we can give this one 0. So the no load current can be determined from the expression of 3.20, 3.21. So IO is equal to root of I working current square plus dengan IM square. So this is from this diagram, phasor diagram. So if you look at this phasor diagram, if you want to find IO di sini, you punya determinant, you need to apply Pythagoras theorem. So IO square is equal to IW square plus IM square. So IO is equal to root of IW square plus IM square. So the value of the no load current IO can also be determined from the no load input power as PO equal to V1 IO cos phi naught. So your IO is equal to, also you can also find IO based on using this equation. So let's look an example di sini. A transformer with a voltage ratio of 2200 and 220 volt. So this is your primary side and this is your secondary side. Takes a no load current of 0.5 ampere. So we can label this one is IO since it is called the no load current, and absorbs a power of 350. So ya bagi clue sudah di sini, it is a no load current. So basically you should have a no load power. Then the question di sini, you need to calculate the iron loss and magnetizing component of currents. So di sini ya sudah kamu cari IW and IM. So based on the information given di sini, kamu kena bagi power, kamu kena bagi no load current, and kamu kena bagi voltage. So you need to solve kamu punya problem ini based on information given. So if you want to use this equation to calculate IW and IM is quite difficult because this equation you cannot masukkan the no load power into the equation. Then you will, if you look at another equation where to calculate I/O di sini based on the no load power. So the equation for the working current and IM di sini, you require the no load current. You require the no load current in order to solve the IW and IM. So back to the equation from the power, PO equal to V1 IO cos phi naught. So PO is given, V1 is given, IO is given, but this phi naught is not given. So you can calculate this phi naught by rearranging the equation. So phi naught, in the end, you can get 0.32. So to calculate the iron loss, IW is equal to I naught cos phi naught. Since I naught is given, which is 0.5 ampere, so you can put into the equation 0.5 kali dengan 0.32, which is from this point, you get 0.16 ampere. Then in order to calculate the magnetizing current, you require sin phi naught. But from this equation, cos phi naught is equal to 0.32. So phi naught is equal to cos inverse 0.32. So you can get an angle di sini. You can label this one X. So sine angle equal to 0.95. So based on the equation di sini, IM is equal to IO sin phi naught. So 0.5 kali dengan 0.95, you get 0.47. So please do try the drill exercise 3.3. So we will continue on the next part of the lecture, which is the rules for referring impedance.